Hey, welcome back to Engineers Workshop. I'm going to try to get some work done on this next project, which is a standoff spacer for the harmonic balancer on my son's Spitfire engine swap. Bear with me because it's really hot. It's mid-90s. Heat index is like 107. I'm not complaining because I know there's areas in the country where the straight temperature is over 107, but you know, it can get pretty miserable in the shop in the still air pretty quickly, so I'll do what I can. At least I'll get the body of this, which is the 2.5-inch tube, chucked in and squared off on one end, and I'll get the boring bar out and I'll see about establishing a nice concentric diameter about a 1/2 inch deep to receive these end pieces. I do have the harmonic balancer over here, so I want to double check some of these dimensions and make sure that this thing will center it up good. And I am not convinced that this is a square hole pattern. I think it might be like two of them closer together and two of them farther apart relative to that indexing pin, but we'll take a look at all that and make sure we make it right the first time. So let's get over to the bench and take a look at the harmonic balancer itself, take a couple of preliminary measurements, and then whatever I finish up today, I will give you an update where the engine assembly is on the Spitfire. He's got that up in the air-conditioned shop, so you know, he works over there. I work over here. But anyway, I'll show you where he's at, because the front end, you know, the whole front accessory drive is really coming together. We've got the fan pulley spacer mounted. He's fitting up the intercooler lines, and it's really starting to look like a nice engine base. So get over to the table and start taking a look at these parts over here. Okay, so we got our 2.5-inch tube, got our harmonic balancer, which does have a serpentine drive pulley on it. And so this guy is going to sit, you know, standing way off in front of where it was. And I hope this concept works out for my son. But if you take a look at the 4 mounting holes for this, we got the 4 mounting holes. We've got this, which might be a locating feature, but if you look at it from the other side, something definitely looks a little wonky with this. I mean, like, these two look closer together than these two. And I can't decide whether it's, you know, 3 are correct and 1 is off, but let's just check a couple of things here for grins. 1.1785. Yeah, he's got this at 1.158, so that's going to have to be increased to be a little bit closer fit. I'm assuming that's what pilot's in here, because the other, in fact, I'm getting a little bigger, 1.184. Yeah, 1.1845. I'm going to mark that down. And just looking at the, you know, inside to inside dimensions on these holes, 1036. Yeah, 0.95. These are not a square pattern. 0.95. 0.85. And 1.025. So we will have to figure out what this is. I mean, it could be all kinds of combinations of either an angular offset, or, I mean, it doesn't look like any of these are a radial offset, but I'll tell you what I could do, which would probably be the most sure thing, is to put this, clamp it down in the K&T, indicate this bore, and then, you know, come over and zero in on each individual hole and use the DRO to record where these are relative to this guy. And I don't know that it matters if I, orient like 3 of them in a straight line. These two definitely don't look like they're centered. It looks like these two might go across center of the center hole, and then these two are shifted. But we'll do something to figure out where these all are, where their absolute position is relative to the center bore. But let's take this guy over, and we've got an ID. I think these are going to be a 2 1/4 inch ID. Yeah. So let's see what this thing cleans up to, and then we'll do some maybe 30-degree weld prep on the end of that after we face it off square. Since I have such a lot of stock to work with, I wanted to get that one squared off and then flip it over, and we'll do the same here. This won't be the finished cut to length, but square both ends, and then we'll play with the counterbore on this end. About 2.265. I don't have to hit any specific number here. I just have to know what the diameter is and then set up for about a 5/1000 press fit. So I'm going to take one more light cleanup cut, and then I'm going to do about a 30-degree weld prep on the OD of that. Okay, I'm just going to run this with the compound, and I'm going to turn it until I have, I don't know, maybe a 120 thousandths long 30-degree land here for the weld bead to lay in. Gotten so used to running the lathe off this VFD, I'm tending to use it more than the gear changes to get my speed dialed in. And so, I'm running this thing like 30 hertz, and I can hear the lathe loading up as I take the cut. But obviously, if I cut my gear ratio in half and put the frequency back up to 60 hertz, it would be an absolute breeze. That looks pretty good. Of course, you're going to have that same, same angle doubled on the other side. So I think this side's done. So when this cools, I'll check what that ID is, and that'll be our target. And for this mating end, we'll just make for a 5/1000 press fit, and probably just heat this up and drop the end into it. Then, of course, I got to get the two ends perfectly aligned with those hole patterns. So there's quite a bit to think about in this to get it to come out correctly. I'm going to get this thing out, let it cool down. Do another 10/1000 and that'll be cleaned up. Okay, we're going to do a quick Spitfire engine bay update. So we're looking at a I can never remember if it's a 1972 or 1974 Spitfire. Original engine, transmission gone, replaced by a VW 1.9 TDI. It's an ALH motor, turbocharged diesel. He's got a remote mount oil plate that was a purchased item. Oil lines go back behind the bell housing. If you come down here, you can see these are custom fabricated motor mounts and the frame piece as well. The cross member for this car was cut out and moved forward as a bolt-in piece so that the engine could drop down lower. The steering rack had to move forward slightly, and those are new solid steel hold downs that I machined on the K&T. Up top we have a full manual fuel pump that was built out of 3 different cores. He had to send 3 different model fuel pumps into this place in Canada who built that fully manual fuel pump. And he's still working on the accessory bracket. Normally, here's the timing belt right here. and the serpentine belt would have been right in front of this. So he's pulled it forward, I'd say a good 3.5 inches on this bracket here. Don't know why he has that clamp on there, but this was the pulley spacer that I made. It's got a double row pulley in there. That's just an idler. Custom radiator, AC condenser, and intercooler. Coming around to this side, you can see the turbo and the intercooler lines, partially aluminum, partially like silicone rubber for high heat. The anti-shutter valve, or cutoff valve, he welded that to this aluminum tube, and I think he's going to use the existing choke cable in the car to pull that shut if the engine would ever tend to run on, or in the case of diesels, they will, if they get an oil leak, they can ingest oil, run away and blow themselves up. So that'll be his means to shut that down. Very tight on this side. He's still got to fit an exhaust in there. Starter's down low. Remote mount oil filter, that's the cooler. And he's got a spin-on filter, which is nice. So he's packaged this up pretty nice. Oh, I don't know if you remember this. This was the factory intake, which was like about yay tall. And I cut that off on the K&T, and then he fabricated this section. I want you to see his welds, welding aluminum. And then take a look at the pieces he bought. I swear to God, he did a better job just as a self-taught welder than some of this purchased items, so I'm pretty proud of that. This is basically two different needle valves that are adjustable to bleed air in or out and act as a, not like a wastegate. This turbo doesn't have a wastegate, it has variable vanes, and this little device will help regulate how fast the boost comes up and what the maximum boost will be. So there it is. It's going to be a neat car. I think he was getting about between 130 and 150 horsepower out of the engine with upsized injector nozzles. I mean, and there's a lot of torque. It's probably between 200 and 250 foot-pounds of torque, because all that power is at a fairly low RPM. And this car, this Spitfire, is going to be 1,000 pounds lighter than the Jetta that engine came out of. So it should be fairly quick for a diesel, diesel sports car, and get tremendous mileage as well. So best of both worlds. Well, I didn't get a whole lot of machining done before the sweat started dripping into my eyes and making it dangerous. So I hope you enjoyed that. We'll pick up right where we left off. Hoping to get a video out next week as well, but I do have the anniversary coming up and going out of town on a little vacation. So yeah, maybe not. Anyway, hope you enjoyed it. We'll continue on with this spacer. I'm going to take it slow and steady so I don't make any mistakes. We got a lot we still need to figure out about it. It looks simple on the drawing, but it's more complex than it looks with the locations of those holes and just getting everything the way it's got to have to be. So hope you enjoyed seeing the update on the engine bay as well. Man, do what you can to stay out of this heat, stay hydrated, stay safe, and as always, thanks for watching. Thanks for subscribing. We'll see you again next time on Engineers Workshop.